To communicate with devices such as a smartphone and Arduino, the smartphone and the device must first be paired. When you run the app, the device list that appears on the main screen is a list of paired devices. If there are none, pair them with the device first. To communicate with a device, the device and communication speed, BPS, must be the same. Touch the menu button at the top. When the menu screen opens, touch the BPS button. When the pop-up window opens, select a speed similar to your device, BPS. From the menu screen, you can return to the main screen at any time by touching the back button on your smartphone. Also, you can return to the menu screen at any time by touching the back button on your smartphone from another work window. If the BPS speed is selected, power on and prepare the device to be connected, and select the device to be connected and press the connect button to attempt connection. It may take 1 to 2 seconds to connect via Bluetooth, and if the connection is successful, the menu screen will open automatically. You can see the status of the device connected, the connected device name, the set BPS speed, and the connection status are displayed. If not connected, neither transmission nor reception will be possible. If there is received data, it will be displayed in this reception box. If you want to view it in hexadecimal mode, check the View Hex checkbox. If you want to clear the reception box, click the Clear button below to initialize it. There is a box to input a command. If you input in hexadecimal mode, check Send Hex and input in hexadecimal type. Hexadecimal should be input in hexadecimal 1-byte units, separated by a space, like OA, 4B, 7F. In this app, all hexadecimal numbers are input like this, separated by a space. Also, you can select and use carriage return below. If you send a pre-arranged command to an external device such as Arduino, it will work. Let's send a command to change the picture on the serial monitor screen. When I sent the picture 3 times, the picture changed. Let's send it again with picture number 6. When I sent the picture 3 times, the picture changed. The name of the left is 6100, and this time, let's change the picture to the right picture, 6200. When you touch the send button, you can see the picture change. In the receiving box, you can see the history of data sent so far. When you touch the button on the touchscreen, you see the data being received in the receiving box. If you send a switch, level value, etc. from a device like Arduino, you can see it here. If you want to use the task window that sends a pre-made list with one touch, you must create a command list in advance. First, let's create a list using the Edit List menu. Let's create a new list to use in List Sender. Click the plus button. First, enter a device name. The list is grouped by device name. You can enter an existing name or a new name. The following explains the title of this command. Please enter it in an easy-to-understand way. Next, write down the actual command to be transmitted. In hexadecimal, each byte must be separated by a space. If you check hex mode, you can transmit as a hexadecimal string, and you can also select and add a carriage character to transmit. Click the Save button and save it. And as you can see, a list is created. If you click on this list, you can edit its contents. You can click on the list, copy its contents, and save it as a new list. So, after modifying the contents as much as you need, click on the Save as New button, and the modified contents will be saved as a new list. You can efficiently create a list by selecting the list to copy, editing the contents, and using Save as New. Once you've finished creating your list, now select the List Sender menu and start working with the list. If you look at the screen, you will see a list of saved commands. Initially, all is selected and all are displayed, but if you select the device name, that is, the category, only the lists belonging to the device name will be displayed. When you touch the list, the saved commands are sent immediately. You can see that it is very convenient compared to the previous work of changing the picture by inputting and sending commands one by one. When you touch the desired list, the contents are transmitted immediately, making it very convenient for testing Arduino or serial monitors. You can work by expanding only the device categories, or you can select all and work while viewing the entire list. There is one more function that utilizes lists, the loop transmission function that can repeatedly transmit this list. If you specify the repetition time interval in milliseconds and click the loop button, the visible list will be transmitted repeatedly in sequence. It will repeat until you press the stop button. DWIN List Sender works similarly to the list sender in the previous chapter, but it is structured so that the header string for the DWIN serial monitor 0A50582 is sent first, followed by the 2 bytes of the target address, and then the 2 bytes of data. Therefore, the user only has to input the target address and value. If you want to apply it to other devices such as Arduino, you can refer to this structure. DWIN List Sender also works by using lists, so it creates and uses a DWIN-specific list. So, let's first create a DWIN-specific list. The trick is the same as before. First, add a list with the plus button. First, enter the DWIN device name. In DWIN, the device name refers to the monitor design. Then enter a description of the command. Perhaps it describes the subject. Next, enter 2 bytes of the target address. In this workspace, if you input a random range, a random value will be generated and a random value will be transmitted. When you click the Save button, a list like the one shown is created. The data is very concise, as the header part is embedded and automatically transmitted. Using the Save as New function we tried out earlier, we create several lists by simply changing the contents. Since there will be several widgets in the DWIN serial monitor, several lists will be needed, so let's create several. Now, let's run the DWIN list. When you select the device list, the corresponding list will be displayed. When you click the loop button, the displayed list will be transmitted, and the data of the widgets on the monitor screen will be changed and displayed. Let's set the delay time and run the visible lists. DWIN's curve is a feature that allows devices like Arduino to display sensor values in real time, giving the feel of an oscilloscope. There are 8 channels, numbered 0 to 7, which means that 8 graphs can be used simultaneously. Here we will test with 0, 3, 4 graphs. First, select a channel number and since it is transmitted as a random value, specify the random value range. Then, specify the delay value transmitted to the graph in milliseconds. Then, let's run from channels 0 to 3. In DWIN Multi-Sender, you can send data to 2 targets simultaneously. Of course, you can use only one by checking Use for each. If you clear Use checkbox of a target you do not want to use, data will be sent only to the checked targets. First, let's send data to only one target. Basically, random data is sent at intervals equal to the delay time. The needle is dancing because the data from the dashboard is sent randomly. Of course, the second target doesn't work since it's unchecked. This time, let's do the data in an up-down manner, not a random manner. This method starts from the lowest value, increases to the highest value, and then gradually decreases when it reaches the maximum value. This operation is repeated. At this time, you can specify the step unit for increasing or decreasing. If it is 10, it will increase or decrease by 10. Let's try operating it with an increase-decrease interval of 5 units. It increases by 5 steps and then decreases repeatedly. If you use both targets, you can test both targets together. You can test them randomly in an up-down manner or however you want. VP is value point, the name of the widget, and when sending a value, if you send data to this address, the value will change. The VP address of the left icon is 60100, and if you send data to 60100, the value, that is, the image, changes. When designing, the VP address of the widget can be freely specified from 1000 to FFFF. But it must not overlap with other widget addresses. SP is stack point, property address of the widget. If you send data to this address, the property value will change. The SP address of the left icon is 6.150, and if you send data to 6.150 plus offset, example, 6.151 is X position data, example, 6.152 is Y position data, left icon's X, Y coordinates will change and move. When designing, the SP address of the widget can be freely specified from 10000 to EFFF, but it must not overlap with other widget addresses. FF00, FFFF address, not available, only system values. If you leave SP as FFFF, it means that you will not use SP. The default is FFF. Let's move the icon by changing the X and Y properties of the left icon. The X coordinate is addressed 6 to 1 to 5 to 1, and the Y coordinate is at 6 to 1 to 5 2, so the two data are sent randomly, and the icon goes to a random location. The range of X for horizontal movement will be around 10 to 630, and the range of Y for vertical movement will be around 70 to 320. This is based on 800 and 480 monitors. Now let's run it. This time, let's send a string to DWIN monitor. Since the header for sending a string is built in, you just need to enter VP address and the string and send it. It was created for the purpose of testing the shape and color of the string. If you enter the VP address and string and press the send button, you can see the string being sent and displayed. You can modify the design by looking at the font position, size, color, and shape. Bit control is a function that turns an icon on and off depending on whether each bit is 1 or 0 using 16 bits of a 2-byte binary number. It has the advantage of being able to turn 16 icons on and off with one VP address. Let's test it like an audio level meter by placing 2 on/off icons in 16 places and turning them on and off by giving them a bit. With DWIN Monitor, you can use your hand to turn the screen pages when the touch screen function is enabled, and you can also send commands from external devices such as Arduino and set the desired screen page. Pages start from 0. Select a page number and press the Send button, and the screen will change. Of course, the number of pages will vary depending on the case. If DWIN Monitor is equipped with a real-time clock, this is a function that corrects the time by sending the current smartphone time. Among DWIN monitors, it can be used for models that have a real-time clock module. You need to read the current value of a widget on the DWIN monitor or read the property value. At this time, you can read the value of a specific address. The number of data to be read can be multiple, depending on the need. When you look at the read data, you can see the VP or SP address, the number of data read, and the current value. The data we just read is the current X and Y coordinate values of the icon we practiced in the previous chapter. How to use is the documentation for this app. DWIN Sense is a description of the header and syntax of DWIN Monitor. Thank you for your interest. We will come back with more features next time.